Hi everyone, welcome to Future Math Lab. Have you ever bought a merch for your favorite artist? You buy one photo card and it's $3. You buy two, it's $6. Three, and it's $9. Notice a pattern? The more you buy, the more you pay, in a very predictable way. This simple idea is a super important math concept called direct proportion. And by the end of this video, you'll be a master at it. So what does it mean for two things to be in direct proportion? It's simple. When one quantity increases by a certain factor, the other quantity increases by the same factor. If you double the first quantity, the second one doubles too. If you triple the first one, the second one triples as well. They move together in a perfect sync. Let's go back to our photo card example. Let's say one card costs $3. We can make a table to see the relationship. Look closely at this table. Do you see a hidden rule? Try dividing the total cost y by the number of cards x for any row. 3 divided by 1 equals 3, 6 divided by 2 equals 3, 9 divided by 3 equals 3, 12 divided by 4 equals 3. The result is always 3. This constant ratio is the key. It leads us to the magic formula for direct proportion. Since the ratio y over x is always constant, let's call that constant a. So y over x equals a. If we multiply both sides by x, we get ta-da! This is the golden rule for direct proportion. In our example, a was 3, so the equation is y equals 3x. Direct proportion is everywhere. For example, the side length of a square and its perimeter. If you double the side length, the perimeter also doubles. The formula is y equals 4x. Another example is the hours you work at a fixed hourly wage and the money you earn. But be careful, not everything that looks similar is a direct proportion, like the number of pages you read in a book and the number of pages left. As you read double pages, the number of pages left doesn't actually double. Or your age and your sister's age. If you're 5 and your sister was 2, when you become 10, your sister won't suddenly be 4. They both increase but not proportionally in the y equals ax sense. What does direct proportion look like visually? Let's plot our photo card example y equals 3x. It's a straight line that passes through the origin 0, 0 and y the origin. Because if you buy 0 cards, which is x equals 0, it costs you $0, which is y equals 0. Simple. Now let's look at the a in y equals ax. This little letter tells us two big things about our line. But wait, what about when a equals 0? That's a great question. If a were 0, our formula would be y equals 0x, which just means y equals 0, always. Think about it. X could be 1, 10, or 10,000, but y would always be stuck at 0. It's not changing with x, so it's not a direct proportion. That's why for a true dynamic proportional relationship, we say a is not equal to 0. We're interested in the fun cases when a is a positive or negative. First, a tells us the direction of the line. If a is greater than 0, the line goes up from left to right, passing through quadrants 1 and 3. For example, y equals 2x. If a is less than 0, the line goes down, passing through quadrants 2 and 4. For example, y equals negative 2x. Second, a tells us the steepness. The bigger the absolute value of a, the steeper the line gets, and the closer it is to the y-axis. Think of it as a steeper ski slope. The line for y equals 5x is much steeper than y equals 2x. Here's a tip that will save you on tests. It's not about the letter a itself, but about the coefficient, the number right in front of x. For example, if I say a equals 5 and ask you to graph y equals negative ax, you might see a is positive and get confused. But the equation is actually y equals negative 5x. Since the coefficient minus 5 is negative, the graph will be in quadrants 2 and 4. always look at the entire coefficient of x, including the sign. Alright, let's recap. 3 key things to remember about direct proportion. First, one thing goes up, the other goes up by the same factor. Second, the magic formula is y equals ax. Third, the graph is a straight line passing through the origin. Great job today! You've just unlocked a fundamental concept in math. If this video helped you, please hit the like button, subscribe to Future Math Lab, and ring that notification bell so you won't miss our next lesson. Got questions? Drop them in the comments below. In our next video, we'll explore its fascinating opposite, inverse proportion. Don't miss it. See you next time.